We have access to the most powerful mapping software in human history. Entire urban models can materialize in seconds. Yet with all this processing power, we still see significant failures in how geographic decisions are made. The problem is the input. If you feed a vague, unstructured prompt into a complex system, the software has to fill the gaps. It begins making guesses about what you actually need to solve. A great tool paired with a bad question will only ever generate a technical answer to the wrong problem. To navigate an era of automated mapping, the focus has to shift. The most critical step in spatial analysis happens entirely outside of the software interface, before a single map is drawn. This is why we use a systematic method to deconstruct problems, the 5W framework. By defining the who, what, where, why, and when, you set the parameters for the analysis before the computer takes over. Now, the process begins with the who. Here, we define the exact units of analysis, the physical features that will actually appear on the final map. This could be schools in London, farms in Kenya, hospitals in Mumbai, or the massive Brazilian watersheds sweeping below us right now. Once you have the entity, you need the what. This acts as a condition filter to narrow the scope of the data. If you are analyzing flood risk for a specific budget, a map of all buildings provides too much noise. You need to narrow that focus to buildings in a flood zone built before 2000. The specific condition is what makes the data actionable. Defining the who and the what ensures your analysis is targeted. Without these filters, you risk producing a broad map that fails to address the specific problem at hand. After filtering the data, we move to the where. This is where we draw the explicit boundaries that give the data its real-world context. There are two parts to this, the geographic scope and the resolution. Both must be defined to match the scale of the decision you are making. For example, if you are trying to place a single fire station, a national-level analysis is too broad. It won't show you the street-level gaps where the service is actually needed. Watch the shift in resolution as we plunge from a national view straight down to a single city block. The level of detail in your data has to match the specific geographic area of the problem. Without matching the resolution to the decision, the map remains disconnected from the physical reality of the area you're trying to manage. The why is the most overlooked component of the framework, yet it is the one that determines if the work is actually useful. When I was a student, I skipped this step constantly. I was more interested in the technical process of making the map than why the map needed to exist. But there is a difference between an activity and a purpose. Mapping flood risk is just the task. Mapping flood risk to relocate vulnerable schools is the purpose. One is a document, the other is a decision. Finally, we define the when. Unlike other types of data, spatial information has an expiration date. Look at the difference in these population maps. If you use a 2018 baseline for a city that has grown 30% by 2026, your analysis will be based on a city that no longer exists. Without a clear why to drive the decision and a verified when to ensure the data is current, you are simply rendering a high-tech version of the past. This 5W grid for a fire station problem transforms a vague request into a specific logic model. It shows exactly which tools to use, network analysis for response times and suitability analysis for available land. Each technical step ties to a requirement. This structure helps avoid common errors, like choosing software before defining the problem, or using a data resolution that doesn't fit the geographic scope. In an era where AI can generate maps in seconds, the human role changes. Our job is to rigorously decompose the question first, giving us a clear way to verify and check the machine's work.
Next, we will take the 5 Ws and apply them to a high-stakes, real-world scenario, figuring out where to build an ambulance station before opening any software.